Centauri B is a planet orbiting the star closest to Earth that looks like Earth. The scientific community has been excited by Michio Kaku's recent discovery of new planets that are even more suitable for life than Earth. You might already be aware of exoplanets in our galaxy that are habitable, planets that look like Earth. Even though the conditions on Earth are suitable for life, why settle for anything less when we could strive for the best? There may be a paradise out there because some planets have more land, cooler temperatures, fewer deserts, and more water. Scientists have identified a number of strong contenders for the human future. Come along with us as we investigate these fascinating planets and the possible routes to reach them. Superhabitable planets may have a greater likelihood of supporting life than our beloved Earth. This idea was put forth in 2014 by John Armstrong and Renee Heller, who argued that it is not sufficient to simply locate a planet within its star's habitable zone to determine its true habitability. It's possible to make a mistake in thinking that Earth is the best place for life to exist. We look for exoplanets that resemble Earth because life as we know it requires liquid water. However, some researchers suggest that other kinds of planets might provide even more favorable environments for life than Earth does. The search for superhabitable worlds embraces the idea that planets may provide even more favorable conditions for the emergence and evolution of diverse organisms than Earth does. A superhabitable world, whether a terrestrial planet or a moon, could potentially support a greater variety of flora and fauna than our own planet, in contrast to the idea that Earth is the pinnacle of planetary habitability. All rocky planets in a zone that can support life are not guaranteed to be habitable. As can be seen in the internal ocean of Jupiter's moon Europa, tidal heating may make terrestrial or icy worlds habitable beyond the stellar habitable zone. Exobiology's wide range of possibilities may be limited by our focus on Earth-like worlds, argue some scientists. A shift in perspective is required for the identification of superhabitable worlds, with a focus on biological factors rather than geocentric or anthropocentric ones. Anthropocentric thinking places humans at the center of the universe and makes them the most important thing there is, while geocentric thinking looks at everything with Earth as a reference point. Astrobiologists think that if we are too focused on finding a second Earth, we might overlook other options like planets that could be better than Earth. Because it calls into question the assumption that Earth is the most suitable planet for life, the idea of superhabitable planets can be difficult to comprehend. Even though our planet is home to an impressive number of complex and diverse life forms that are able to survive in harsh environments, this does not necessarily mean that it is the most habitable planet in every way. Heller and Armstrong suggested creating an exoplanet profile that would include things like stellar type, planetary mass, and location within the planetary system in order to broaden our search. Scientists are now looking into orange dwarf star planetary systems as well as yellow dwarf stars like our Sun in the hunt for life. These stars, which are cooler, brighter, and smaller than our Sun, provide a different perspective on the possibility of life-rich planets there. It's possible that our Sun isn't the best type of star for supporting a planet with a lot of life. This viewpoint challenges the idea that the solar system around Earth serves as a model for life elsewhere in the universe. Red dwarf stars outnumber yellow dwarfs by about 50% across the vast Milky Way galaxy. Orange dwarf stars have much longer lifespans, ranging from 20 billion to 70 billion years, compared to our Sun's estimated lifespan of less than 10 billion years. Planets in their habitable zones benefit from this longer lifespan by having more time to support the growth of life and accumulate biodiversity. Older planets have advantages, but they shouldn't be too old, given that complex life on Earth took about 3.5 billion years to develop. These planets may eventually run out of internal geothermal heat and lose their geomagnetic shields. As a result, the sweet spot, or optimal age range, of 5 billion to 8 billion years has been proposed by researchers. Earth, on the other hand, is approximately 4.5 billion years old right now. Size and mass are also important. The capacity of a planet to support life is closely linked to its mass and size. A planet larger than Earth would have a larger surface area that is habitable, possibly supporting an atmosphere that is more extensive and stable. On a planet that is 10% larger than Earth, ideal conditions for life may exist. Additionally, due to its interior's prolonged radioactive decay, a planet with 50% more mass than Earth would continuously generate heat. As a result, the planet's molten core and crucial magnetic field would remain intact for a longer time, opening up more opportunities for life's birth and development. Additionally, increased gravitational effects enable the planet to maintain its atmosphere for a longer period of time. The environment is better for life the longer it lasts. However, if we ever visited such a planet, increased gravity would make it more difficult for humans to move around, but this may not be as significant as the difficulty of reaching such a planet in the first place. Temperature is also crucial. Superhabitable worlds may exist on worlds with a temperature difference from Earth of only about 8 degrees Fahrenheit. This is due to the possibility of larger tropical zones on a warmer planet, which, as observed on Earth, encourage greater biodiversity. In comparison to other regions, tropical rainforests have a remarkable diversity of life because of their warm and moist climates. However, because of the expansion of deserts brought on by increased heat, planets with higher temperatures may require even more moisture. After all, the search for planets that are habitable relies heavily on water, which is a fundamental requirement for all life on our planet. Planets with land masses comparable to Earth's, but divided into smaller continents, may also provide a more favorable environment for life. In the past, when continents were very big, like the supercontinent Gondwana 500 million years ago, their interiors were far from the ocean and turned into huge, hostile deserts. There is a greater diversity of life in our world's shallower seas than in their deeper counterparts. As a result, researchers have begun to speculate that planets with smaller water masses would be more suitable for supporting a wide range of life forms. When it comes to exoplanets, some of these conditions are beyond our current observational capabilities, but researchers continue to look for these indicators. Alpha Centauri b has emerged as a particularly promising target in this endeavor for locating a superhabitable planet. The stellar system that is closest to our planet, Alpha Centauri, includes Alpha Centauri b. We have not yet confirmed any planets in Alpha Centauri b, much less superhabitable planets, despite the system's exciting potential. One was reported in 2012, but in 2015 it was found to be false. In 2013, observations suggested the existence of another, but this is still unconfirmed. Therefore, Alpha Centauri b does not contain any known worlds. However, what about its nearby planets, such as Proxima Centauri? As a red dwarf, Proxima Centauri may also have planets that are habitable or even superhabitable. The fact that it is only 4.2 light-years from Earth is a bonus. Therefore, what kind of planets does it contain? Proxima Centauri b, an exoplanet in the red dwarf's habitable zone, is one of 3 planets. Proxima C and Proxima D are disputable. It is one of the exoplanets that is known to be closest to our solar system. Is it habitable on this planet? Well, less than you might think. Due to a number of factors, life cannot thrive on Proxima Centauri b because of significant obstacles. The tidal locking phenomenon and the activity of the star make it hard to live on this planet. Proxima Centauri's UV radiation is, on average, redder, which may make it less likely that organic compounds will interact with it. Additionally, it's possible that this UV radiation will produce less ozone. The ozone layer may even be disrupted by the star's activity, resulting in increased UV radiation that could be harmful. During specific phases of its journey, Proxima Centauri b may temporarily be outside the habitable zone due to the eccentricity of its orbit. The planet's potential to be habitable may be affected by this fluctuation. The presence of oxygen and carbon monoxide in the atmosphere is another consideration. These gases have the potential to be toxic if they are accumulated in large quantities. On the other hand, complex organisms may evolve more quickly in environments with higher oxygen concentrations. Tidal forces may cause coastal landscapes to flood and dry out in cycles if Proxima Centauri b has oceans. These variations might encourage the emergence of biological rhythms similar to day-night cycles and trigger chemical reactions that are beneficial to life development. Because it is tidally locked, Proxima Centauri b would not experience day-night cycles on its own. However, these flooding and drying cycles could also help the oceans mix and distribute nutrients and cause periodic expansions of marine organisms, similar to red tides on Earth. Even though red dwarfs like Proxima Centauri have lifespans that are significantly longer than those of our Sun, they do not produce oxygen-generating photosynthesis-friendly radiation. It's hard to say for sure whether Proxima Centauri supports anoxygenic photosynthesis. According to a 2017 study, a photosynthesis-based ecosystem would be only 20% as effective under Proxima Centauri's light as our Sun, making it challenging to generate sufficient energy for widespread life support. However, let us return to the Alpha Centauri system. Alpha Centauri B is a great place to look, even though no confirmed planets have been found there. The James Webb Space Telescope could help us see it, but the Breakthrough Starshot project is a more exciting idea. By developing lightweight, light-powered spacecraft that are able to travel at a significant fraction of the speed of light, roughly 15 to 20% of the speed of light, to reach nearby star systems, this groundbreaking breakthrough initiatives project aims to transform space exploration. The objective of the project is to investigate the Alpha Centauri system, including Proxima Centauri, in order to possibly locate planets that would be suitable for colonization or superhabitability. We might be able to find superhabitable planets that humans might one day call home if everything goes according to plan. But what exactly is a superhabitable planet? It has conditions for life that are even better than those on Earth. Around an orange dwarf star, there is a planet that is slightly older, larger, and warmer than Earth. It has shallow water masses and a variety of land masses. These kinds of planets might be better places for different kinds of life to grow and develop. The search for superhabitable worlds forces us to look beyond